Hey guys, in this video we're going to be discussing how to make a script that makes your head move side to side while you move your camera or your mouse. So let's get started. Okay, so first things first, what you're going to want to do is place a local script inside of StarterGui, since we're going to be working from the client, and I'm going to go ahead and name this head move script. And you're going to want to call the player. You can put game.players.localPlayer because local player is inside of the client. Next, you're going to want to get run service. And wait for the character. So once you wait for the character, you're going to want to call the character. So char equals player. And then you're also going to want to call the torso. And for R15, you're going to need a new way to call the torso, which is upper torso. So you can just do that by doing char find first child torso for R6 or char find first child upper torso for R15. And then you're going to want to call it neck, since the neck joint is what we're going to be working off of. So it's neck equals torso.neck. Alright, so now that we have everything set, we can get the camera. So local camera equals workspace.currentCamera. And another reason we're using the local script is because you want to get current camera, which is only located in your client. And we're also going to want to get mouse, just in case you want to use mouse instead of camera. So you get player, you get mouse. You're also going to want to make an event that fires every time the render steps. So run service dot render step connect function. And basically what this does is it runs an event every single time that the render steps, which is 1/40th of a second. Alright, so what you're going to want to do first is get the look vector of the camera. So we'll call this LV camera.coordinateFrame.lookVector. And we're also going to want to get the normal vector, which is the look vector of the torso. So torso.cFrame.lookVector. Alright, so now that we have these two vectors, I'll explain the math behind them right now. Alright, so when you're dealing with two vectors in 3D space, let me make a circle. I'll move that right there. Okay, hold on. Okay, so we have two vectors in 3D space, but we're really worried about the x and y and x and z axis, since we're working from side to side. So here's the center. Should look bad. Okay, so there's the center, and here we have the normal vector. Right, let me make that a different color. We have the normal vector, which I'll call n. And we also have the look vector, which is the camera's vector, which I'll call C. So we have C, and we also have N. Now, what we want to do is calculate this angle right here, so we're able to turn the head. So there's two ways to do this. We can do the dot product, or we can find the angle of this right here using its x and z, and we can find the angle of this normal vector using x and z, and subtracting the two to get this angle right here. So the dot product way is you would have the dot product of C and N would be equal to the magnitude of C times the magnitude of N cosine of theta. So we're looking for theta in this case, so we'd make theta, or we can divide the magnitude of C and the magnitude of N on both sides, and we'd get C times N divided by magnitude of C times the magnitude of N equal to cosine of theta. And since we're solving for theta, we can turn this into cosine, or inverse cosine is equal to, or the inverse cosine, okay, we're solving for this angle, so we have theta is equal to the inverse cosine of C times N over the magnitude of C times the magnitude of N. The thing about this though is theta is always going to be positive, and in order to turn the head we need it to be positive and negative, so it could turn to the right as well as the left. In this case it would only turn to the left since theta would always be positive. It needs to go this way as well. So another way to do this is by doing the first method that I explained. So what we could do is find the angle that C is pointing at and then the angle that N is pointing at, and subtracting the two to get theta. So since 2D vectors have two components to them, we have C, which would be equal to its I component and its J component. We could find the angle of this by doing the tangent. So let me visualize this for you guys. We have vector C, and we have its I component and J component. So I and J. Since we have I and J, we can calculate theta here. So to do this we can use tangent. So theta would equal the inverse tangent of J over I. Then we also have the normal vector, which would always be this way. But since our character can rotate different directions, it's not always going to be towards 1. So we're also going to have to find that angle. So it would be theta, it would be the same method, so tangent negative, or the inverse tangent of J over I. So we have two thetas right here. We have the angle of C and we have the angle of N. So to find the angle between those two, we can just divide, or we can subtract both of the angles. So we can do the angle of C minus the angle of n. Oh. But since we're actually looking for the angle between this and this, we need the difference of n and c. So it needs to be the other way around. So it would actually be, let me cross that out. The angle of n minus the angle of c. Oh. And we can simplify this to tangent -1 could do nx over ny. Oh, actually my bad, the other way around. It'd be ny over nx. Minus tangent of cy over cx. But since we're dealing with x and z, it wouldn't be cy or ny, it'd be nz and nx. So let me change that real quick. So nz and c. And this would give us the angle between the two vectors. So instead of using the dot product, we could use this method to actually get a positive and negative value of the angle. But this could come useful as well, so let's also get that. Okay. So now that I've explained the math, let's go back to the script. Okay, so now that we discussed the math, we can finally go back to scripting. So what we discussed was that we could use the product, or the angle of the look vector and the angle of the normal vector to actually get the angle between them. So what we're going to do first is get the angle of the look vector. So get look vector angle is equal to math.atan2. We'll use the atan2 because we need it to be positive or negative, and atan2 is really good at doing that. So we'll do lv.z since we need y, and then lv.x. And we're not using y, we're using z this time because we're moving side to side. So same thing with nv. So local nv angle equals math.atan2 nv.z and nv.x. So to get the angle between them, like we said in the math part of this video, we do nv angle minus lv angle, and that will give us the angle between the two vectors, positive or negative value. And so if we did everything correctly, it would look something like this. So let me script it into the neck. So neck.c0 is equal to cframe.new 0 and 0 times cframe.angle math.pi divided by 2 math.pi. These are just the initial components. It's 90 degrees in the pitch direction, 90 degrees in yaw, and then this is what we're scripting. We're scripting the roll. So it'd be angle at the end. And if we did this correctly, it should work. So when we move the camera around, the head moves with it. But the problem here is that when we look like directly behind us, the head will also look directly behind us, which is something that is not supposed to happen since it's not realistic, right? We need it to move 90 degrees at most. So let's script that in. So this is how the dot product comes in handy. So what we want to do is find the dot product. So dot product is equal to, let me make them into vector 2's so that it's easier. So lv.x and lv.z dot, this will return the dot product, which is a really handy function. So dot, and then we'll also make another vector 2 for the nv, so nv.x and nv.z, and that'll give us the dot product. And we also need to find the product of the magnitudes, so magnitude product, I guess, is equal to, we can find this by using the Pythagorean theorem, so math dot square root, and then we do lv.x squared plus lv.z squared times math dot square root, and then we have nv.x squared plus nv.z squared. So that'll give us the product of the magnitudes of both of the vectors. And now we can find the angle. So local absolute angle, since it'll be positive, equals dot product divided by the magnitude product, or the inverse cosine, so math.a cos dot product divided by magnitude product. Okay, so this should give us the angle. So what we want to do now is, if the absolute angle is greater than 90 degrees, so math.pi divided by 2, then, well, if we do math.pi divided by 2, there's also a chance that the angle might be greater than 90. It might be like 90.1, and it'll look really weird. So what we want to do is make it like 89 or something, so it's greater than 89. So I'll convert this into degrees. So times 180 divided by math.pi is greater than 89. Then, if you're confused on what I just did right here, I just turned radians into degrees by using this right here. So that's why I put 89 now, because if it's greater than 89, this will act. So what we want to do now is make another variable right here, and so if the absolute angle is greater than 89, then the angle will equal the last angle, and the last angle, we're going to script it so that the last angle will always be the angle that was before the angle that's being scripted during this event. So else, if it's not greater than 89, then the angle, or we'll make last angle equal to angle. Okay. So here we have everything done, and it should work if we did everything right. So now, as you can see, I can't turn my head more than 90 degrees this way or this way, doesn't matter. So there you have it. I'm also going to teach you one more thing, since it looks really choppy right here. One more thing you can do so that it doesn't look choppy is use the lerp function that comes with C-frame. So you can do nec.c0 lerp. And for those of you who know what lerp does, it basically gets the initial C-frame and the goal C-frame, and it subtracts those two and gives it a integer between 0 and 1, and whatever that integer is, it'll go to that like specific zone. I'll leave the link to lerping in the description just so you guys can see like what I'm talking about, because it's really hard to explain, but this is basically what it does. mostly for animation purposes. So after using the lerp function, this is what it should look like. So right here, it'll go smoothly back to where it needs to go. Instead of being choppy like it was before, it'll do the same on the other side as well. So there you have it. Oh, I also forgot. So if you want to use the mouse, all you have to do is, instead of using camera, you use mouse dot unit ray dot direction, since direction is just basically the unit vector from the mouse to its position. So that's really all you have to change. And there you go. You can use your mouse now. Alright, so I hope you enjoyed this video, and I hope you learned something. And stay tuned for more videos. Make sure to like and subscribe, and I hope this helped you out. Alright, I'll see you guys later.